Hi, Assalamualaikum and greeting to all. Today we are from Group 1. We present about our group project, and the title for our group project is Designing a Retaining Wall to Maintain Stability of a Region by Applying Engineering Mathematics. Okay, so next is our group member. First one is our leader, Ching. Okay, next is assistant leader, Nur Kamila binti Taidi. Next is Siti Khadijah Shamsul Dahri. Next is Nur Hanani Akasha bin Abdul Halim. Last but not least is me, Amir Huzaifah bin Syaful Bahrain. So next, we go through for introduction. Okay, background of study, we have 5 points, which is first, there have many topic in the field of engineering mathematics, okay, which is such as calculus, linear algebra, tangent plan, partition derivative, okay, differential equation, probability and statistic, numerical method, and so on. So now we focus to tangent plan, which is a tangent plan can be considered when a plan that touches a surface at a particular location and has the same orientation as the surface. Okay, next, tangent plan equation can be expressed as n1 in the bracket x minus a plus n2 in the bracket y minus b plus n3 in bracket z minus c equal to 0. So the tangent plan equation useful for surface analysis, optimization, and comprehending the local behavior of a surface in differential geometry. And for our project, okay, tangent plan will be used to design a retaining wall to mitigate the risk of soil erosion and maintain stability in a region. So we go to a problem statement, okay, which is a soil erosion or significant rain cause a slope to erode, gravity force, rock, soil, and other material to slide down, okay. And by using a retaining wall to fortify the soil boost it carrying capacity and raise the soil resistance, okay. And for our project, they have a specific point, okay, which is 0, square root 2, and 8, okay, is identified at hilly region, okay. Okay, so the function of z is equal minus in bracket x square plus y square close bracket plus 10, okay. Okay, so we have 3 objectives for our project, okay, which is the first one is to identify the method that can be used to solve the problem statement, okay. Second is to apply lesson or skill gain from engineering mathematics subject, okay, to address issue in the real world situation, okay. And the last objective is to design a retaining wall by taking a tangent plan as a reference.
Hi, my name is Nur Kamila Zaidi, CF22004. I will explain about literature review in this project. The first one is according to James Stewart in his book, which is Calculus, Early Transcendentals. Tangent plans are essential tools for investigating the characteristics of curves and surfaces in differential geometry. They provide definitions for crucial ideas like normal vectors, curvature, and tangent bundles. All things considered, the tangent plane offers a local approximation of a surface or manifold at a particular point, enabling us to comprehend its behavior and properties in the region of that location. Next is according to Manfredo Pido-Carmo in his book, which is Differential Geometry of a Curve and Surfaces, a tangent line is the base linear approximation of a curve into dimensions at any given location. The best flat approximation to a surface at a particular point in three-dimensional space is represented by a tangent plane. Therefore, according to L. Debnet 2003 in his article, applications of fractional calculus to science and engineering, by their very nature, many engineering problems fall into this category, making the employment of numerical methods to discover solution crucial for engineers. One-dimensional questions have various uses, especially in the content of time and space. That's all from me. Thank you.
Now I explain the tangent plane methodology. Let's consider a function of two variables fxy and a point AB in a domain of function. The goal is to find the equation of tangent plane of surface defined by fxy at the point AB. Here are the steps involved in the tangent plane methodology. First, calculate the partial derivative. Find the partial derivative df over dx and df over dy of the function fxy with respect to x and y respectively. Then evaluate the function and its derivative at a given point. Substitute the given values of a and b into fxy, df over dx, and df over dy to obtain fab, which is df over dx multiplied by ab, and df over dy multiplied by a. After that, construct the equation of the tangent plane. The equation of tangent plane can be written as z minus fab equals to df over dx multiplied by ab multiplied by x minus a plus df over dy multiplied by ab multiplied by y minus b. In this equation, xyz represents a point of the tangent plane, and fab are the values obtained in step 2.
So I'm going to explain about the calculation part. So the hilly terrains can be represented by the function z, which is z equal to negative bracket of x squared plus y squared bracket and also plus 10 at the point of 0, square root 2, and 8. So let the 0, square root 2, and 8 the coordinate become x0, y0, and z0. And also we can find the fx and also fy. So based on the equation z, we can find fx is equal to negative 2x and fy is equal to negative 2y. By substituting the point of x0 and y0, fx will get 0 and also fy will get negative 2 square root of 2. After we found fx and fy, we can substitute into this formula z minus z0 equal to fx x0 y0 times x minus x0 plus fy x0 y0 times y minus y0. And also we can get already the tangent plane equation is z equal to negative 2 square root 2y plus 12. And already this plane already shown as the diagram. For discussions, the tangent plane can be used as an outline or guide when designing a retaining wall by placing the retaining wall parallel with the tangent plane corresponding to the natural slope of the surface. The wall is stable and effectively supports soil retentions. First, the tangent plane will be helpful for slope alignments while planning the retarding wall because the tangent plane represents the slope of the land at certain locations of a point. So the retarding wall is aligned with the tangent planes to match the slope of the ground, which increase the stability and it can prevent also the soil movements. When the wall is not aligned with the tangent plane, the soil lateral force may impose unequal pressure on it, and it will create instability and also even sliding. So next, the tangent plane can also be used to establish the slope orientations depending on how steep the slope appear of the surface or of the terrains. It may be necessary to add a butter which a little inward or outward inclination of the wall face. The tangent plane slope can also be used to determine the butter inclinations to ensure that the wall is aligned with the overall slope of the ground. If the retarding wall is positional to match with the general slope of the ground, it will withstand the lateral stresses created by the soil more effectively. So the butter helps to distribute the pressure more consequently, and it can reduce the chances of sliding or overturning. Next, tangent plane can also be used to structure the retarding wall in a visual appearance manners by matching the retarding wall with the tangent plane. A smooth and natural transitions between the wall and slope is made possible. The walls seem to be bent in with the surrounding by following the natural art of the landscape. This architectural style allow the retarding wall to bend in with the surrounding, providing an attractive and inviting appearance. And because it eliminates sudden change in height, retarding wall aligned with the tangent plane have a more natural and soft appearance. This design approach is especially important for landscapes such as parks or gardens, even resistant area where pursuing the environment is artistic harmony and natural beauty is a priority. So besides that, it also can be used to design the draining system. Because draining system must be installed along retarding wall, it's aimed to prevent water from accumulating behind the wall and weakening it. A good draining system collect rainwater and direct it away from the retarding wall. Water drains from the slope must be managed carefully to minimize build-up and potential hydrostatic pressure against the retarding wall. The draining systems must be designed to prevent hydrostatic pressure that accumulates behind the wall, which could undermine the structural stability. So at here, tangent plane will be playing an important role to design and used to as a reference to design the draining systems to prevent the cases happen. So next, the height of the retarding wall may be determined based on the quantity of soil retention necessary and standard for retarding wall constructions. The equation of tangent plane also gives the height of the terrains at a location that was selected. This information will assist in determining the proper retarding wall height. The elevations difference between the wall base and its highest points along the tangent plane must be taken into account while designing the wall. When the retarding wall is aligned with the tangent plane, the lateral force created by the soil are more evenly distributed. This increases the wall stability and long-term performance by reducing the risk of uneven pressure and sliding along the face.
So in conclusion, the hilly-terrain tangent plane was found using the function z equal to minus x squared plus y squared plus 10 that represented the hilly terrace at the point 0, 0, 2, 8, which is in danger of erosion. A better understanding of the problem is produced by illustrating the graph of the function z and the coordinates z 0, 2, 8. An equation of tangent plane to the surface z equal to fxy at point x naught y naught z naught, where x minus z naught equal to fx x naught y naught times x minus x naught plus fy x naught y naught times y minus y naught was applied to obtain the tangent plane. Tangent plane of the hilly terrain is z equal to minus 20 to y plus 12. When building a retaining wall, the tangent plane could be used as an outline or a guide. The tangent plane will be a helpful reference for slope alignment, slopes orientation, construction drainage system, or even integrating the retaining wall in an aesthetically pleasing way while designing the retaining wall. The determination of tangent plane in this study helps us to learn more about usage of engineering mathematics methods in civil engineering fields.
The retaining wall may be constructed by using the appropriate materials and aligning the first level with the predetermined base level of the tangent plane. Moreover, retaining wall is effective and provides optimal soil retention when it is positioned parallel to the tangent plane, which corresponds to the surface natural slope.